Okay, so when we have congruent polygons, the definition of congruent polygons is two polygons are congruent if and only if. IFF means if and only if. If you see that, it means if and only if. Kind of biconditional there, or yeah. Two polygons are congruent if and only if their corresponding parts are congruent. So when we look at polygons, we're going to have to determine what are the corresponding parts and are they congruent. On your paper, you've got two polygons. We have polygon ABCD and we have polygon EFHG, or EFGH, I'm sorry.
What's that arrow of them?
If and only if. Okay. Order's important. A, B, C, D, E, F, G, H. Order of how we name things is important when we're talking about congruent figures. Are these polygons congruent?
Yes.
How do you know, Brandon?
Because all the angles are congruent and all the measures of the sides are congruent.
Okay, so corresponding angles look like they're congruent and corresponding sides are congruent. So let's be sure everybody understands what those corresponding parts are. Okay, let me shrink that just a little. Okay, let's talk about corresponding angles. What angle corresponds to angle A?
Angle E.
Angle E. And in this particular set of polygons, they are congruent. What angle corresponds to angle B? Armando? Angle F. What corresponds to angle C? Darby? Angle G. And angle D, Casey? Angle H. And notice when I named these polygons, I made sure that I named them in the same corresponding order. Okay, we don't want to mix those up because that can make a big difference. Okay, let's think about our corresponding sides. Juliana, what side corresponds to side AB? Side EF, good. And we want to name it in the same order. What corresponds to side BC, Zach? What corresponds? FG. And then what corresponds to CD? What side corresponds to CD, Monica? GH. And what corresponds to side DA? Will? Mm-hmm. HE. We want to say HE, not EH. Okay, so we've got our corresponding angles, corresponding sides. So quadrilateral ABCD, because the corresponding angles are congruent. Since all of these are congruent to each other, we can say that those two quadrilaterals are congruent. These are congruent to each other because we have all of the sides and all of the angles marked. Therefore, quadrilateral ABCD is congruent to quadrilateral EFGH. When we're talking about corresponding angles here, it's not the same as corresponding angles of two parallel lines cut by a transversal. So when you hear the term corresponding angles, you have to go back and look. Are we talking about polygons or are we talking about parallel lines? Because they're different depending on the application that we're looking at. Let's go to the next sheet that you've got. Okay. Here I have some different scenarios. First of all, I just have a diagram. And what we're going to end up doing is naming the triangles that appear to be congruent. And we can do that based on part 1 and part 2. But notice that triangle in part 1 is really the same triangle that I have at the top. All we did was, well, get rid of this. And those are the same. So we wanted to see if we can name these so that we have congruent triangles. Or see, does it look like we have congruent triangles? All right, notice in the number 1, the angles at P on either side of the vertex P are congruent. How do we know that those are congruent? Lucas? They're vertical angles. So obviously those are going to be congruent. And I've marked some other angles so that we can see what's congruent and what's not. And when you are going to be determining if you have congruent polygons, it's a good idea to mark angles for congruence. All right, so we know that angle P is congruent, angle M is congruent to angle N, and angle L is congruent to angle O. So we could name, one way that we could name this is triangle PML, and that is congruent to triangle PNO. Order makes a difference. I could not say that triangle PML is congruent to triangle PON because I'm not going in the same order of congruence. If I wanted to say triangle PLM, what triangle is that congruent to, Leah? Triangle OPN? Is that right, Armando?
Would it be triangle PN?
P what N?
P.
I don't have a D. That's an O.
Oh.
PON? Is that right?
Yes.
Yes. Because we're going from P to L. Notice L has 3 marks, so I have to go from P to O. Starting at the same angle, but going to the ones that are congruent. What if we said triangle MPL? How would I have to name the other triangle? Kate?
NPL is congruent triangle NPO.
NPO, good. We okay on that? Order is very important. Okay, let's look at the next one. Notice this is the same as that original, but we just pulled them apart. We went back and we kept that part where I have the squiggly line, but I pulled those apart, and now I have 2 triangles. And I have identified congruent angles. So tell me 2 triangles that are congruent, Shelby.
Triangle L and
NMO? Is that, Cameron, you don't agree with her?
it would be ONM.
ONM. Notice if I'm going to start at L that has 3 little marks, I've got to start at O that has 3 marks. And I went from 3 to 2 to 1, so I have to go from 3 to 2 to 1. Gilberto, what's another way that I could name these congruent triangles?
NML and MNO.
NML is congruent to, say it again,
MNO.
MNO?
Yes.
Okay. Brandon, what's another way I could name congruent triangles?
M and L, or did we already? No, we didn't.
MNL,
Wait, we just,
did we?
No.
oh, M N, oh, okay, and then M N O. Wait,
Okay, so let's go back and look at the previous one. Is it right? We said, okay, NML and MNO. That looks right. So if we do MNL, we have to do NMO. Because notice we started with 2, so we have to start with 2. Make sense? Okay, let's look at the last page. Okay, we're going to find some values here. I'm told that polygon MNOPQ is congruent to polygon VUTSR. But notice these pentagons are not in the same, they're the same shape, but they're not facing the same direction. So I've got to figure out what's congruent to what. So let's see what we can do. And that's based on how they're given. If these are congruent, that means that angle M is congruent to what? Angle V. So angle M is congruent to angle V.
no,
Is that not right?
no, it would be angle N and B.
Look at how they're named. Look at how they're named. You go in the same order. What is angle N congruent to? U. So in a case like this, it might be a good idea to mark your congruent angles, and it's based on the order that the polygons are named if you're told they're congruent polygons. Yes, sir?
So X is 40.
Well, hang on. We're not there yet.
Okay, so slow
No,
down.
thanks, son.
Okay. Angle O is congruent to what?
T.
Angle O is congruent to angle T. And angle P is congruent to S. I'm going to change color. Well, actually, let me do it black. And that leaves R and Q, which I've already marked. But it's always a good idea, especially if you're like me and you don't see things well translated or shifted. See, my brain doesn't work that way. Those of you that are artistic don't have any trouble seeing those shifts. But I have trouble seeing it. So for me, it's helpful to mark my congruent angles. So now that we know that angle R and angle Q are congruent, what did you do to get the answer, Kason? What did you do to find X?
Well,
What would you do, Leah?
Would you do x plus 90 equals 133?
X plus 90 equals 133. So what is X? 43.
why isn't, because it's not if you turn that, it's the order they go in.
We have to decide what angle's congruent to what. Because this may not only be shifted this way, it could be reflected. It could be flipped.
Yeah, because it's not converted.
Because if we were just to lay that on its side, it wouldn't match up. If we were to lay this one on its side, Kason, I don't think it would match up, and it's also flipped over. So it's important to match up congruent angles based on how they're named. Yes,
So it couldn't be 83 then, since it's not in the, right?
correct. All right, let's look at how to find D. Okay, now here we're going to go back and look at, yes, ma'am.
I found the answer.
Okay, well, hang on just a minute. If we look at side MN, that corresponds to what side? VU. Okay, so that may be important. All right, so we're trying to find D, so which side are we going to look at?
NO and UT.
Okay, we're going to look at this UT and NO. So what is side NO? Okay, now you can tell me, Estelle.
Okay. D equals that.
Well, how did you get that?
Okay, 2D minus 5 equals 9, and we just solve from there.
Okay, so we add add 5, and D is 7. But we want to be sure that we're looking at the right sides. And you can tell which sides you need to be looking at based on the order of the name of the polygon, since we're told they're congruent. Okay, not too bad. All right, how can we classify polygons? What are ways that we can classify polygons? What's one way? Either convex or, how can you tell if it's convex or concave? Concave kind of is going to cave in. That's not the official reason, but when we're looking at it, I told you, you can tell because a concave is going to cave in. Yes, sir?
By the number of sides.
By the number of sides. How else can we classify a polygon?
Oh, regular and irregular.
Regular or irregular? What's the difference?
Is a regular.
What's the difference, Will?
Is it like all the sides are congruent?
For which one?
Randomly?
Regular polygon has congruent angles and congruent sides. So if I wanted to find the sum of all of the interior angles, how would I go about doing that, Shelby? Lucas?
Do the number of sides minus 2 multiplied by 180.
N minus 2 times 180. Now that is in your note cards.
That would give you the sum of all of it, but then you have to divide by the number of sides to get each individual.
Only if it's a regular polygon. If you have a regular polygon and you wanted to know the number of sides, you can do n minus 2 times 180 divided by n. So if you know what the sum is, that would be your formula to find the number of sides. What's the sum of the exterior angles of a polygon? Darby?
So the exterior.
Mm-hmm. 180. Armando? 360. It's always 360 degrees. So if you wanted to find 1, you would divide 360 by n if it's a regular polygon. If it's not a regular polygon, you cannot determine that. Trying to think what else we might need to know. I think that's somewhat a review. If we are thinking about, if we're given 2 sides of a triangle, or let's say we're given 3 sides of a triangle, how do we determine whether or not those 3 sides actually make up a triangle or not? Monica? If if you've got three sides or three lengths and you want to determine, will these make a triangle, what do you do? How can you determine if they make a triangle?
You get the two shortest angles and you add them up.
And then what?
And then you determine if it's more than the longest.
Okay, it's two sides. If we take the two shorter sides, the sum of the two shorter sides has to be greater than the sum of the longest side. What if you have two sides of a triangle and you want to find your possibilities for the third side? What would we do then? Zach? Anthony? If you have two sides of a triangle and you want to find your possibilities for the third side, how do we do it?
You subtract it, you find the difference and
Okay, the difference has to be less than the third side, which has to be less than the sum. You just did that on your homework. Okay, we're going to take our quiz. When you finish the quiz, on page 289, you have 1 through 10 and 12 to 14. And, 289, excuse me. 1 through 10, 12 to 14, and 22. Estelle, you had a question?